Hi, welcome to YouWillUnderstandMath.com. Today I want you to understand why limits are needed. You've probably heard about limits in your calculus class or some other course. I actually have a problem here that I want to present to you that helps explain why limits are used. Okay, it's a great scenario of why we use limits. And here's the problem. Suppose a bowling ball is dropped from 100 feet above the ground. The equation modeling the height of the bowling ball is h of t equals 100 minus 16t squared for t seconds after the ball is dropped. What is the average rate of change of the ball from the time it is released until the time it hits the ground? So I have a little picture here that shows what's going on. We have a bowling ball here, and it's initially at 100 feet, and then it falls to the ground until it's here, okay? So we see that the height is 100 feet here and the height must be 0 feet here. We'll use those pieces of information to help us answer this question. After all, the question is, what is the average rate of change, which we know we usually need 2 points to figure out. And we want to know what's the average rate of change from the time it is released, meaning when the height is 100 feet, until the time it hits the ground, when the height is 0 feet down here. That's what we want to figure out in this problem, okay? So let's do it. Here's our original function, h of t equals 100 minus 16t squared. We'll need 2 points, and I'll write these 2 points using indices, those little numbers. So our first point will be t sub 1, h of t sub 1, and our second point will be t sub 2 and h of t sub 2. So t sub 1 will be the initial time when the ball is released, and h of t sub 1 will be the height when the ball is released, which we know is 100 feet because that ball was released from 100 feet in the air. So we can go ahead and write that part down. Okay, h of t sub 1 will be 100. That's when the ball is released. And then the second point will represent the time the ball hits the ground, and h of t sub 2 will be the height of the ball when it hits the ground, which we know is 0. Okay, so these outputs will be in feet, the heights will be in feet, and then the time will be in seconds. Okay, so that's what we need to figure out. But we can do it because we know this equation here. So if we know that the initial height is 100, I can plug in 100. 100 equals all of this business, 100 minus 16t squared. Well, I don't think we have to do any more work because you can look at this equation. We see that we have 100 on both sides minus a term that has t involved. So that means that t must be 0 in order for this equation to be true. In fact, if you plug in 0 here, then you'll have 100 minus 0, which is 100. So we'll go ahead and save ourselves some work and write down t sub 1 is 0. T sub 1 is 0. Okay? Similarly, we can do the same thing to figure out what's t sub 2. We can do the same thing for t sub 2. We know that the height at t sub 2, when that bowling ball is on the ground, the height will be 0. So that means that we'll replace h of t with 0 and solve for t. Okay? So h of t will now be 0. The other side would be the same, 100 minus 16t squared. And then we just solve for t, but we know that we're solving for t sub 2. I just won't write the little 2. We know what we're looking for, okay? So I'll add 16t squared to both sides. Add 16t squared to both sides. Now we have 16t squared equals 100. We're solving for t, so we'll divide both sides by 16. And then we have t squared equals 100 over 16. Well, we don't want to know what t squared is. We want to know what t is. So that means we need to take the square root of both sides. And we would normally do the plus or minus square root, but we know that time is positive, so we don't need the negative version. We'll just use the positive version. Positive square root of 100 over 16. That actually comes out to be 2.5. And remember, this is time, so it's actually seconds. 2.5 seconds. So that's what t sub 2 is, 2.5 seconds. All right, so now we have our 2 points. We can plug into our average rate of change equation. I'll call it ARC, average rate of change. That will be h of t sub 2 minus h of t sub 1 all over t sub 2 minus t sub 1. Okay, let's plug in. H of t sub 2 is 0. H of t sub 1 is 100. So we have minus 100. And remember, this is feet because that was the height of the bowling ball. T sub 2 is 2.5. 2.5. And then T sub 1 is 0. And remember, these are in seconds because we were talking about time in seconds. On top, we have 0 minus 100, which is negative 100 feet. On the bottom, we have 2.5 minus 0, which is 2.5 seconds. If we divide negative 100 by 2.5, we'll get negative 40. And of course, that is feet per second. Okay, so we answered that question. We know that the average rate of change is negative 40 feet per second. Well, what does that mean? So let's go back and look at that problem again. All right, so we found out that when we found those 2 points, we used the point when the bowling ball was 100 feet above the ground and t was 0 seconds. That's what we found in our scratch work. And then we found out that the ball was on the ground at 2.5 seconds. So over the course of those 2.5 seconds, that bowling ball is falling at 40 feet per second. 40 feet per second over the course of 2.5 seconds that it fell. Okay, how about you try this? Try part B. Here, we want to know what's the average rate of change of the ball between 2.4 seconds and 2.5 seconds. Now, the difference between this question and the question that I just solved was that in my problem, I was going from 0 seconds to 2.5 seconds. In this case, you want to find the average rate of change from 2.4 seconds to 2.5 seconds. So go ahead, take a look at that, try and work it out, press pause, and then when you're ready, press play. All right, so hopefully you worked that problem out. I'll show you the answer at the very end. For now, I want to move on to my next question. Notice here in part C, okay? Now, this will be the exact same problem. Our height function is 100 minus 16t squared. And this time I want to know, how fast is the ball falling when it hits the ground? How fast is the ball falling when it hits the ground? All right, so if I wanted to work this out, if I try to use the average rate of change, which is what I used previously, well, in this case, we'll have the same time and the same height for both points. So we'll be looking at 2.5 seconds for both points. And then, of course, the ball would be on the ground, so the height would be 0 for both points. Okay, so when we plug in here, the height will be 0 twice, and the time will be 2.5 seconds twice. And we'll be subtracting here. So we actually get 0 over 0, which is a problem. We cannot have a number in this form. It doesn't work. So this is the case where we actually need limits, because you can't find the average rate of change using the same point twice. In this case, we need the instantaneous rate of change, which is what limits are all about and what calculus is mostly about as far as differentiation. So this is what we'll be looking at in the near future, limits. Okay, so usually if you want to find out what's going on when a number gets sufficiently close to a place where it's going to be undefined, or what happens as numbers get extremely large, or what happens as numbers get extremely small, then we look at limits. So that's the whole point of using limits. I hope you've enjoyed this video. If you have, please give me a like and feel free to subscribe. Thank you.